Well, hello children. So I'm gonna go over the review right now. It's already 5:30, so I really apologize that I already went past the time I was gonna post it, but I had tutoring, so forgive me. I know that my 7th period children wanted a shout out, so a shout out to Jose from 7th period and Edgar from 7th period. All right, so let me go ahead and get started. And I'm going to start with number 1. And it says to create an area model for this maze. Find the probability of getting a pumpkin. So the first thing I'm going to do is I'm going to create my rectangle for my area model. And there are 3 original paths, the upper path, middle path, and the lower path. So I'm going to divide this into 3 pieces. So 1, 2, and then that makes a third one at the bottom. The first path, if you see, it goes into 2 places. So I'm going to divide these in half. One of them has no pumpkins and the other one has pumpkins. The middle one only goes to 1 and it goes to pumpkins. And finally, the last one goes to pumpkins and no pumpkins. Now, this one is cut into 2, that one's cut into 1, and this one's cut into 2. The least common multiple of 2 and 1 is 2, so that means this middle one needs to also be cut into 2. So this one's going to be pumpkins and that one's going to be pumpkins. So now, there's a total of 6 pieces. 1, 2, 3, 4, 5, 6. And 4 of them, 1, 2, 3, 4. Have pumpkins, and we simplify this is 2 out of 3. That's for number 1. That's all you have to do. Now number 2 says create an area model for this maze. I'm going to start by drawing my rectangle for my area model. I'm going to try to make it kind of small. And there are 4 original paths, 1, 2, 3, 4. So I'm going to make 4 pieces to start off with. Now this first one goes to 1, 2, 3 different ways. So I'm going to divide it into 3. And then the next one goes into 1, 2, 3 different ways. So I'm going to divide it into 3. The next one goes into 1, 2, 3. I apologize for that sound. It probably sounded so loud right now, but sorry. That was 3, and they're all pumpkins. And then finally the last one goes into 1, 2, and I divide it into 2. I think this one was no pumpkins and then pumpkin, pumpkin. Same thing for this one. This pen's going crazy already. I hope it doesn't go crazy the whole way. And then all these were pumpkins. And then this one was no pumpkin and pumpkin. Now I do have 3, 3, 3, and 2. 3 and 2, their least common multiple is 6. That means this row needs to be cut into 6, this row needs to be cut into 6, that one, and that one. So if I'm gonna cut into 6 and I have 3 pieces, each of those has to hold 2, because 2 times 3 gives me 6. And then of course, same thing over here. And then this one I have 2, so each of those needs to hold 3. Now if each of those is holding 6 and there's 4, 6 times 4 is 24, so the total is 24. And then I can go and count all these that have a P. That's 2 plus 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 3. It's a lot of them. It's actually 17, I believe, if I remember correctly. I think I do. I have good memory, hopefully. And then I need to get 50 people that show up. Oh, I did that real ugly. 50 people showing up. How many pumpkins does it have, or do you need for those 50 people? So I'm gonna set a proportion up with the 50 on bottom, and I'm looking for this. If I cross multiply and divide by 24, I get 35.41. So x equals 35.41. I'm gonna round it up though to 36 pumpkins, because if this is a real life scenario, I would rather have an extra pumpkin than be missing a pumpkin if that 0.41 person decides to show up, right? Not 41, but another person. But yes, even though this is a 41 and you would round down, I would round up just because of the real life scenario. Number 3. Number 3 says create a maze that fits the area model. So this one, I'm just gonna start writing yes, no, yes, no, yes. These are all the possible exits I can have. I could do more because it doesn't tell me you can only have 5, you can only have 1. So all of these are exits. I have a starting point. And there's 1, 2, 3, 4 original paths. So 1, 2, 3, 4. And then the first one goes to a yes, no, no, yes. That means I have 2 yeses and 2 no's. And then the next one goes to no, yes, no. If I attach it to that one, that's already going to be the 2 no's, and then I need 1 yes. This one right here has yes, no, no, no. I need 3 no's and 1 yes. If I attach it to that one, that's already this no and that no and this yes. I'm missing 1 no, so I can make one over here to create the last no. Finally, this one has a yes, this one has a no, so I can go for no and yes. That's how my maze would look like. Now I need to find the probability of yes and no. I'm going to erase this over here. Probability of yes and no. I have a 4, a 3, a 4, and a 2. The least common multiple of 4, 3, and 2 is 12. That means each of those rows is going to have to be divided into 12. Now I have 4 pieces. That means each of them need to hold 3, because 3 times 4 is 12. I have 3 pieces on the next row, so each of them needs to hold 4, because 4 times 3 is 12. And then this one's the same idea as the first one. Then I have 2 pieces, so each of them needs to hold 6. Each row is holding 12. 12 times 4 is 48, so there's a total of 48. And I'm going to find the probability of yes first. And I already said the total is 48. So I got to go in there, and I'm going to add all the yeses. So 3 plus 3 plus 4 plus 3 plus 6. And if I remember correctly, that was 19. Now I gotta find the probability of no. Still out of 48. So I'm gonna go ahead and add all the no's. 3 plus 3 plus 4 plus 4 plus 3 plus 3 plus 3 plus 6. All of that is 29. Now you could have also done it the short way. If there were 19 over here, 48 minus 19 gives you 29. So I could have done it that way to get this answer, right? Or count. They're both pretty simple. It does say to explain your reasoning, so don't forget to do that tomorrow, because then if you do, it's going to be a very sad story. Number 4, create an area model and a tree diagram to show the probability of drawing a marble from each jar. Then find the probability of drawing 2 black marbles. Also find the probability of at least 1 gray. So for this one, I'm going to start by creating my area model, and we said we're going to create it like a Punnett square. The reason we're creating it like a Punnett square is because they are all equally likely. All of the marbles are the same size and so on. Jar 1 is going to go vertically. So I'm going to have a white marble, another white marble, and a black marble. They're coming from these right here. And then the top is going to be jar 2. So I have 3 white ones and 1 black. I'm going to split it up and then fill in these blanks, W, 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 B, W, and so on. Sounds like I'm saying a website or something, but it's just my Punnett square. There's a lot of writing. I wrote it all day today and I'm still going at it. But anyway, I'm done. Filled it out. And that's my Punnett square, my area model for that part. Now I also need to make a tree. And I have my starting point. Jar 1 is displaying 2 colors, black and white. There are 2 white marbles out of the 3, and there is 1 black marble out of the 3. That's jar 1. Now I'm going to focus on jar 2, and there are 2 colors displayed on that jar, black and white. There's 1 black out of 3 and 3 white. Sorry, and it's not out of 3. It's out of 4. It's 1 out of 4, and then 3 white ones out of 4. This one is still talking about jar 2, so it's the exact same thing. So I have my tree. Now I need to find the probability of 2 marbles. So probability of black, black. I'm going to put this one up here. On my Punnett square, the only black, black is this one. So that is 1 out of 12. For my tree, probability of black, black, I have to follow the branch that has black and black. So I have 1/3 times 1/4, which is 1 out of 12. Now I also need to find the probability of at least 1 white. And it says gray because they're supposed to be gray on my worksheet, but on yours they're white. Okay, you didn't notice that yet. Hopefully now you do. At least 1 white. This one has at least 1 white. That one, that one, that one, that one, that one. All of these have at least 1 white. They're 11. So probability of at least 1 white is 11 out of 12. And then now I gotta do the same thing for my tree. Probability of at least 1 white. That means I gotta follow all of the branches that have white, white. So for example, I'm gonna follow this 1/3 and this 3/4, and then 2/3 and 1/4, and then 2/3 and 3/4. But that's a lot of multiplying, and I don't want to do that because I'm lazy, and there's a shortcut, so why not just use a shortcut? I know that if I add all the probabilities of the outcomes here, it's going to give me 1. I'm going to put a 1 there. And the only one I don't want is the one that's highlighted in yellow, this 1/3 times 1/4. So mine is 1/3 times 1/4, because I want the ones that have at least 1 white, and that one would be black, black. So 1 minus 1 out of 12, which is the same as 11 over 12. We get the same answer, but they are worked out a little bit differently. Okay, that's for number 4. We're almost done. Hopefully my video saves because I just did a lot of work. Number 5, first thing I want you to note is that in this case, I decided to already give you, to already give you the answers that you should be getting when you multiply your branches. All of these branches are already multiplied for you, okay? Now, that's just something you want to note because some of you guys were trying to multiply those in there too, and it's not what that is, okay? Now, first thing that it's asking is to give a scenario that could be modeled by this tree diagram. I'm going to go back to the one that had boys and girls, so maybe A is for boys and B is for girls. And then this is for the orange color and this is for black because we are in Halloween mode. C is for orange and D is for black. Orange is my favorite color, by the way. If anybody guesses that tomorrow, I'll give you 1 point. Alright, so my scenario could say the tree diagram represents the boys and girls that like orange or black. I'll take something like that so we don't have to sit here and write for the rest of our lives. That's good enough for the scenario, okay? So I just answered this part. Give a scenario, blah, 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 that gives something about this tree. Now, I'm going to clear that just so the next part doesn't get all weird, but probability of AC. AC, I already gave you the answer right here, okay? But I'm just going to write it down just in case tomorrow the test doesn't have them. So 0.3 times 0.82, which is 0.246. That is my answer. Probability of not AD. So probability of not AD. That's interesting because there's two ways. The hard way or the easy way. Hard way is not AD. That means I can take AC, I can take BC, and I can take BD. Everything except AD, right? But that's a lot of multiplying, and like I said, I'm lazy and I don't want to waste my life doing that. So instead, I know that when I add all these, it gives me 1. And the only one I don't want is AD. So minus 0.3 times 0.18. And like I said, the answer was already there. So 1 minus 0.054, which is 0.946. I think that's what it was. I don't remember exactly, but hopefully it was. And then finally, probability of C. That means you gotta take anything that has a C. So this path, oh, I just did the wrong one. This one and that one has a C. This one and that one has a C. Okay, so I'm gonna do 0.3 times 0.82 plus 0.7 times 0.35. We said that this was 0.246 plus 0.245, which is, I believe, 0.491. And this will be my answer. Oh, and that was my answer for that one. Okay, that is it. I hope you guys find this video useful. Oh my god, I can't even talk anymore. I hope you guys find this video useful. And I'll see you guys tomorrow. Hopefully everybody gets 100. Bye, guys.